Assalamualaikum warahmatullahi wabarakatuh, and hi. Today I'll be presenting regarding a new design and simulation of smart sensing for emergency vehicles. So, Malaysia has the fourth worst traffic congestion condition in Asian countries, with the second highest carbon dioxide emission levels. Although the traffic condition in Malaysia is not as bad as our neighboring countries, traffic congestion is really an emerging issue, especially in developing countries like Malaysia. The increase in urban population and middle class segment contribute significantly to the increasing number of vehicles, hence traffic congestion and delays are increasing all over the world. The evidence indicates that traffic congestions will eventually lead to slow traffic, increasing the travel time and overall making it one of the major problems in metropolitan cities. Therefore, it is imperative to improve the efficiency of transportation, especially when attempting to use the emergency vehicles. All emergency vehicles are designed and licensed to respond to any emergency. Not only that, but emergency vehicles are also permitted by law to violate the usual rules of the road to get to any destination as quickly as possible, such as crossing an intersection at a red light. So, during an accident of emergency, the victim's life depends on mercy of others. In addition to that, there's also a delay of emergency vehicle reaching a specific site due to heavy traffic. So this delay may increase the likelihood of a victim's death. Therefore, to overcome this drawback, it is essential to strategize and minimize the travel time for emergency vehicles to operate at their full capability. Thus, preemption or time division can be an aid for emergency vehicles to reach their intended destination in a significantly shorter amount of time. With this, we can clearly see there is a need towards the application of smart sensing for emergency vehicles. So this study approaches an application of smart sensing to address the alarming traffic congestions. So the goal of this project is focused on the design and the simulation of the e-bus smart sensing for emergency vehicles using software. The aim of the e-bus simulation of smart sensing for emergency vehicles is to ease the authorities that are responsible to react to emergencies such as ambulance, police, firefighters, and many others responsible authorities. So, the goal of this study is to address the above-mentioned problem. First and foremost, to develop and prioritize information from real-time traffic monitoring to provide a faster emergency response without compromising safety. Next is to evaluate method using this case study for the efficiency in providing a faster emergency response and minimizing its delay on the traffic. Lastly is to develop complete simulation of smart sensing for the emergency vehicle using the software. The scope of this project is bound to the case at Pekan Bukit Pasir, Muar, which is located at Johor, so the traffic flow is heavy during the rush hours. Hence, the simulation of this project will be conducted during the rush hours. The number of vehicles increases during these specific rush hours. Therefore, the accuracy of the simulation is highly expected to be realistic based on the traffic flow. Based on our observation, by visiting Pekan Bukit Pasir, Muar, Johor, we have collected information related to our objective to improve our real traffic simulation, as this project is still being developed according to statistics. So the traffic flow is heavy during the peak hours, which is between 5 p.m. to 7 p.m. and the simulation will be conducted, which I've mentioned earlier, will be conducted during peak hours, and the estimated car is between 30 to 50 during these peak hours, and sometimes it exceeds more. So from this project, there are three things mainly we want to achieve. First and foremost, to develop a proactive approach that uses real-time traffic monitoring information to provide faster emergency response without compromising safety rules of the road. Secondly, to develop a system based on the siren characteristics to detect the siren from emergency vehicles effectively and can respond promptly. Lastly, conduct a complete simulation on smart sensing work on the approaching of emergency vehicles towards traffic light. So what you are seeing here is the design of the e-bus system or the e-bus device itself. Some designs from previous studies became our sample designs that others had done throughout the earlier design phase, and some fresh concepts were developed. This design also uses the concept of a traffic light that's a single signal light besides a sensor to inform the road users. The aim of this design is to have a big dimension to provide a suitable space for other electrical components and make it easy for emergency vehicle drivers to recognize the signal light. The design of the device is approximately not bigger than a traffic light to avoid confusion to other road users. This design also takes the effectiveness of the sensor working principle to increase the volume of the emergency vehicle siren by implementing the audio amplifier to run on this system. To have the effectiveness of the sensor, the best place for the sensor is outside of the device. So this is our first lookup of the eBus that produces from the SolidWorks. It takes a lot of time to figure out this idea, but the main and side components of the eBus, so there are 13 parts of this eBus device, can be divided, which comes with siren base, siren cover, rotating part, bracket, microphone bolt 20mm, bolt of 10mm, mount hook, nut, pole, display screen, and display screen mount. The table below shows the material selection of the eBus. All the selection materials that will be utilized have certain tasks and functions that are required to make the product well functioning. To make the device operate well, we make sure to make the right choices and decision of the material that be worked to ensure that the project objective can be achieved and fulfilled. Thus, after having a thorough discussion and researching, we have decided the material for our device. For the siren base and siren cover, we decide to use plastic. One of the reasons is because it is tough and have resistance toward rusting and UV stabilized to provide years of safety. As of the rotating part, we use high strength low alloy steels as it can maintain the formability and the weldability. For the bracket and the bolt, we use and both bolt, we use stainless steel. We all know the stainless steel is highly durable and due to its corrosion resistance and durability. So for the mount hook, we use alloy steel as it has high tensile strength and easy compressibility. For the nut, we use stainless steel due to it has high durable and it is also corrosion resistant and durable mainly. For the pole, we use alloy steel. For the display screen, we use LCD, high energy efficiency and low power consumption. The main reason why we decided to use LCD display. For the display screen mount, we use alloy steel as it has high tensile strength and easy compressibility. So, which I have stated earlier, the aim of this new design and simulation of eBus for emergency vehicle is to ease the authorities that are responsible to react towards emergency situations such as the ambulance, police, firefighters, and many others. The main factor to ensure this simulation works depends on the type of sensor used and its application and the reliability of it. It is to denote that the sensor is very sensitive to its environment. The functionality of the sensor is to detect the sound of emergency vehicles and react immediately by giving a signal to the parallel traffic light to change the indicator from red to green. However, there are other consequences which affect the efficiency of the sensor. This problem may lead to traffic congestion on the road. Heavy-duty traffic, due to increase in number of vehicles, produce a lot of waves for the sensor to detect unnecessary frequencies and traffic light conversion will be volatile. Thus, prevention of the sensor waves and frequencies are utmost important for us to ensure the success rate of this eBus device. The applicability of the sensor such as ultrasonic sensor, color sensor, light sensor are testable with prediction for the success rate of this project. So the table here shows the sensor justification on why we choose microphone sensor as our main sensor for the eBus device. So here are basically the pros and cons of each sensor, and the microphone sensor is chosen due to its capability to ignore various waves and frequencies and has a high detection level for the sound of the emergency vehicles. The pole stress calculation of the eBus device is based on the knowledge and application of solid mechanics, which focuses on the bending stress. The aim of the calculation is to find the maximum stress and efficiency on the pole which holds the eBus. So here is the calculation of the pole stress. We also did a Google form to check on the data collection on those authorities. So basically, one of the questions we asked is whether this innovation to reduce travel time for emergency vehicle will help the authority. So from the data obtained, we can see about 94% of the people agreed that by doing this innovation may help to reduce the travel time for emergency vehicles. And also, we also did ask whether the relevancy of this study, and about 74.2% agreed that this study is relevant. Moving on, we also did the engineering analysis of the whole eBus itself, where we did the pressure analysis and the displacement analysis. So, for the pressure analysis, as shown in figure above on the top. So, the sections that are represented with color is to identify the region that exerted the force. So, the highest region that experienced the highest amount of stress is at the middle of frame plate with the stress about 3.426 megapascal. So this comes to show that this device, eBus, will be able to support from 98.1 Newton of external forces. As of the displacement analysis shown in figure below, so URES called resultant displacement, which referring to the deformation result. So the highest region that experienced the highest amount of URES, which is the resultant displacement, is 0.001 unit. So this result shows that deformation does not occur when external forces is applied. So this comes to show that the E-bus device will be able to support the load applied. Deformation does not mean material failure. It just means that a component was displaced beyond its elastic capabilities and will have a permanent deformation once unloaded. The results finding concerning the existing streets condition at Pekan Bukit Pasir, Muar Johor, and the simulations of model of the E-bus device concept that applied in the PTV VSIM will be discussed shortly. So here is the video of the simulation of the PTV VSIM shown. There are 4 streets access existed from the Pekan Bukit Pasir. So here I'll play you the simulation for you. The first simulation modeling was conducted by implementation of one approach, which is following the data traffic flow latest. The PTV VSIM simulation results are presented in table 4.3 as you can see. So this table 4.3 shows that after conducting the first simulation modeling, the average vehicle speed passing these 4 streets are different each street. Queue delay, acceleration, vehicle is other main parameter that recorded from software in order to minimize the time travel. For the first simulation, we just ran the software by using the data traffic that we got from observation at Pekan Bukit Pasir area. This data will be compared at the last simulation in order to see the difference in statistical value after applied this E-bus device concept. The second traffic management simulation modeling was implemented in one approach. The approach was to shift traffic flow circulation from the 4 main streets. After implementation of the second simulation, the performance of the street can be seen as follows in the data. So as you can see in table 4.4 and the figure, it was the statistic that recorded that we have obtained from the PTV VSIM software. So for the second simulation, the data can be divided into 3 main parameters, which is the time travel, distance traveled, and the members of vehicle on the street. For the third traffic management scheme was conducted by one approach as well, which is adding the detectors for the 2 main streets, which is Jalan Muar Labis 1 and Jalan Muar Labis 2 street. This is because the E-bus device concept focusing the 2 main roads often traveled by ambulance or the emergency vehicle, road which authority vehicles such as ambulance and police uses. So I've said focusing on 2 main roads which often traveled by the emergency vehicle. So the PTV VSIM simulation results are as shown in table 4.5. You can see. So from the table 4.5, we can see that there are certain improvement in the vehicle speed parameters passing through these 4 streets after applied the E-bus device concept at the average of 16.28 meter per second to 29.01 meter per second. A reduction of the queue delay at average 37.01 second to 57.39 seconds. This comes to show that the concept will smooth the traffic flow at the 4 main streets. So for the fourth traffic management simulation model, which was implemented in one approach as well, it is although same as the almost the same approach as the third simulation, but the results vary. So after implementation of this fourth simulation, the performance of the streets can be seen in table as shown, table 4.6 and the chart here. So for the simulation of by PTV VSIM clearly shows that the difference in travel time with and without the E-bus, there's a large gap in data. So with the presence of the E-bus, travel time data for ambulance is minimal. So based on the data recorded via the simulated broadcast, it is shown that this E-bus device will help to respond to ambulance journey or any authority vehicle journey. So here is the advantages, disadvantages and future improvement of this E-bus system. So as of the advantages and disadvantages, there are 2. For the advantages, clearly based on the data shown, it clearly shows that can cut down the time travel and comes to show that we are able to reduce the travel time for this emergency vehicle, and this directly saves the victim's life if any accident or unwanted things happen. So the authority vehicles can reach to its intended destination with minimal time. For the disadvantages, to do the fabrication of the E-bus itself, it requires a huge cost and it takes a long time to produce the product. For the future improvement of the system, there are 3 mainly I would like to suggest. First, decrease the cost to produce of the product. We can do more research and development on how the production cost can be reduced and saved. Secondly, we can find ways to reduce the production of the product. Maybe we can, in the future, we can do more research on where the time in processing the e-bus can be cut. Maybe we can simplify the system. And lastly, find a sensor to detect emergency vehicles, a more advanced and suitable sensor to detect emergency vehicle siren. The insights and results gained from this study draw conclusions that are consistent with the purpose of this study. Judgment and choices are done with useful resource of the use of reasoning. While the design and simulation of the e-bus smart sensing model indicates a completely unique view of the study, the findings strongly indicate the relevance and the need towards the smart sensing for emergency vehicle within the emergency response unit, such as police authority, fire department and rescue authority, healthcare department, and the list goes on. There isn't any missing values within the fact set, and the response on the survey is satisfying, where we gained a total of 62% rate achieved. For the limitation, this study is limited in time-wise. The 1-year term to complete this study, the time constraint can also affect the completion of this issue for this research and case study project. So besides that, another limitation faced on the study on conducting the 3D printing, where there are several limitations from the aspect as time allocation, the machine specification on doing the digital fabrication 3D printing, and allocation and human error when operating the 3D printing machine. As of the contribution and implication of this study, this was the first and successful of a comprehensive information of design and simulation of smart sensing for emergency vehicle tested via PTV vSIM. This research project will bring a significant impact on Malaysia's traffic response towards emergency cases. Now, there are various research and proposals of intelligent traffic system that's intended to react towards emergency vehicle. This simply shows and validates that there is a need and reflect the good acceptance and the applicability of the model which is proposed. A new design and simulation of smart sensing for emergency vehicles demonstrate a qualitative methodology by examining the relevance and impact of this project. This study recommends that in any interdisciplinary field of research, it is important to understand the key elements within the identified field of study. Initial design and simulations were key to understanding this study. For the respondent for the specific search must first be identified. It is important to know and identify the expert in this research area, as this can help document and streamline the scope of this project. Study the theory. We also have to study the theory to have a solid knowledge of the applicability of this study. So this exercise will be extremely helpful during the analysis phase. The data collection is done over a time frame, and the data sets are then filtered. Allocate time should be sufficient to avoid false assumption. Additionally, the simulation of the PTV vSIM software, which is used for the simulation to run this project, is based on a free trial. So therefore, for the future recommendation, by using this free trial PTV vSIM, there are certain limitations, and the presence of watermark is there when we are conducting the software. So when using this software, our recommendation is to apply for a license from the PTV authorities for a research-based license. So for the closure of this paper, a new design and simulation of smart sensing for emergency vehicle, it has been successfully completed by applying the knowledge of mechanical and civil engineering. So the finalized design of this e-bus has been greatly generated and has been fabricated using a 3D printer. After the simulation of smart sensing for the e-bus, we can say the simulation was successfully conducted. This is because the results and data obtained from the simulation for both before and after the implementation of the e-bus, the results obtained is sufficient to prove and answer the objective of the project, which is to minimize the travel time of emergency vehicle. So from the simulation, we are able to deduce that this project will be practical for implementation for our case study, which is located at Pekan Bukit Pasir, Muar Johor, and not forgetting the opportunity of this project for the acceptance and implementation in Malaysia. There's a high potential. This new study, design and simulation of e-bus for smart sensing regarding emergency vehicle has also explored the important determinants of this study. This determinant will give a huge influence on minimizing the travel time for emergency vehicle. With that, I'd like to say thank you.